Thank you.
Okay, so next we're going to change topics. Going to kind of go back to looking at monitoring data. In particular, we're going to be looking at OpenTelemetry and InfluxDB, so you can get that really nice observability view into what your applications are doing with our own Jacob Marble. Jacob, are you ready?
Hear me okay?
Yeah, cool. So don't forget, get in the Slack channel so you can start popping the questions there or into Slido, because I know this is going to be a great talk. So thanks, Jacob, and take it away.
Okay. Well, good morning, InfluxDays. My name is Jacob. I work on, I'm a member of the IOx team here at InfluxData. IOx is InfluxData's new storage engine. And during this talk, we'll be discussing observability signals, storing observability signals in IOx. All right, so a little bit about me. My wife and I have 3 children. We live in the United States in Idaho, which is in the mountains in the west part of the country. Mountains, lakes, trees, all that kind of thing. During the pandemic, I learned how to fly small airplanes, which is makes it even easier to appreciate this part of the world. So let's start by describing the current generation InfluxDB storage engine. It's called TSM, and it's a columnar storage engine built on top of what's called a log-structured merge tree. If you're not familiar with log-structured merge trees, they are a way to store key value data in memory and on disk in a way that is particularly good for write throughput. Happens that query performance is also very good for patterns typical of time series use cases. I said that TSM is a columnar storage engine, and that isn't not true, but it isn't the whole story. So the in-memory and on-disk columns aren't columns of field values, but they're columns of series values. It's a subtle difference, and it's important only to appreciate the improvements that we're making in IOx. So for example, if you were to store, let's say you have a measurement with one field, and that field is represented or tagged with a total of 4 series, well then in TSM that would be 4 data columns, not 1 data column. So TSM has served our customers and our open source users very well over the years because it can store hundreds of gigabytes of data and cardinality into the millions. Query performance is best with selective analytic queries, that is to say, queries that read like up to thousands of series and queries that perform mathematical operations across millions of values. Strong use cases include IoT, metrics, and events. And I've put a little star next to events here because TSM is a very good way to store event time patterns, like data with irregular time intervals. But some event patterns imply cardinality that exceeds best practices for TSM. So we will now contrast that with IOx, which is our next generation storage engine for InfluxDB. It's been in development for over a year now. The native IOx file format is Parquet, which is an open source column-oriented data storage format. Parquet is a very common format in the big data ecosystem. It's been around long enough to enroll in the 2nd grade. So IOx is a columnar storage engine like TSM, but a column of field values is a column of Parquet values. So cardinality grows with field quantity, not series quantity, and we anticipate that most, if not all, cardinality worries will be resolved with IOx. Critically, IOx is designed from the ground up to store data in object storage. TSM performs very well on SSD storage, and IOx leverages the much cheaper storage from something like S3 or Blob Store, Google Cloud Storage, Minio. Can also be configured to use a locally mounted file system or just keep the data in memory. Even better, IOx can be configured to cache Parquet objects on a local file system or in memory. So we aren't sacrificing performance by doing this, we're merely increasing capacity. So IOx is designed so that data distribution and data lifecycle are flexible The open source IOx storage engine can be deployed as a cluster of nodes in multiple regions, with nodes serving various types and sizes of workload. For example, you could co-locate your time series database with your applications that are emitting those data, and then forward a subset of that data stream to a larger IOx cluster or data lake at some central location. So, next slide. Reconnect to client. Having a little bit of a slide issue here. Better. This is the slide that I want. Some of our customers and open source users have expressed interest in storing higher cardinality data within InfluxDB. These are people who love the frictionless user experience that InfluxDB delivers in enterprise, cloud, or open source, but they have novel use cases that demand higher cardinality and larger storage capacity than TSM can deliver today. Storage capacity and storage cardinality are essentially unlimited, as mentioned before with IOx. Query performance is now primarily limited by the network, cache misses to object store, and streaming results back to query client. And that can be solved with improvements to the network layer. Later on, we're using Aeroflight, for example, to stream query results. Strong use cases for IOx include IoT and metrics, as with TSM, but now the star next to events has been removed. IOx is great for storing all kinds of events, including logs and traces at scale. Logs and traces are mentioned here just because they're a common high cardinality use case, but several niche use cases exist. So let's dive deeper. Could you advance the slide once for me? Thanks. Let's dive deeper into a specific time series use case, and that is observability. The definition of observability is a little bit slippery. Charity Majors deserves a lot of credit for popularizing this term in our industry, and you can learn more about her perspective on observability from her blog at charity.wtf. For our purposes, let's just define observability signals as traces, logs, and metrics. So OpenTelemetry is this fabulous project. It's the rebirth of open tracing and open census. It's a single standard for logs, traces, and metrics, not only a standard, but also a full SDK in many languages, programming languages, and it's also implementation of delivery agents for these signals. Second most popular CNCF project in 2020 behind Kubernetes, and strong backing from all the important names in APM and cloud service providers. So today, let's talk about what the world looks like today before OpenTelemetry. This is just a typical observability stack for a tech company that's trying to use open source products. They're emitting, collecting, and querying observability signals. Metrics, logs, and traces are gathered in dramatically different ways. Metrics are instrumented with a Prometheus SDK, collected in the Prometheus exposition format. They're pulled, not pushed, by an agent like Telegraph. They're stored in InfluxDB, queried and visualized with something like Grafana. Now, that's just metrics. That's the top row. That's red. So to describe logs, let me start by saying, forget everything I just said about metrics because it's completely different. Logs are instrumented with printf or some wrapper around printf. Now think about that for a second. Printf, we're printing something like dot matrix printers and dumb terminals and 80 columns. It's nuts. This is how we log today. Anyways, we print f into some quasi-standard like log funct or JSON. We push via standard out, completely different mechanism to the pull mechanism via HTTP that we use for metrics. An agent like FluentD somehow captures that standard out text to streams, attempts to parse tags or labels from that stream, and then feeds the result to something like Mongo, where it can be queried and visualized with Graylog. All right. Traces, on the other hand, are newer So the idea of the concept of tracing is newer than logs and metrics. So the situation here is a little bit better. If you've chosen to use Jaeger to improve your life, then you get to instrument your application with the Jaeger SDK, and then push spans through a Jaeger protocol to collect and deliver the spans with the Jaeger agent, and then the Jaeger collector stores those spans in something like Elasticsearch. And then conveniently, Jaeger has its own UI. So, like, to me, this is just, I think that in 5 years, this madness will be regarded as silly and expensive and old-fashioned, like when my university professors complained about punch cards, or when their college professors complained about software bugs as literal bugs in tubes before transistors. Anyways, back to OpenTelemetry. So because OpenTelemetry is one standard and one implementation for all of our observability signals, the story is completely different. We instrument our application once with the OpenTelemetry SDK, and we collect those signals by pushing OTLP messages. It's just the OpenTelemetry standard protocol. We send those messages via gRPC to an agent, and that agent is called the OpenTelemetry collector. And now we have this nice stream of observability signals with a single implementation, a single instrumentation, a single stream of data, a single collector. But where do we put those signals and how do we observe them is the big question. So before we get into collection and query, here are some roadmap items relating to migration from the madness to OpenTelemetry. Many of the OpenTelemetry SDKs, yes, this is the slide that I want. So on the left here, you see that we instrumented the application with the OpenTelemetry SDK. We can do that, and many of the SDKs will still emit through these, let's call them legacy formats. So the Rust OpenTelemetry SDK is capable of exposing Prometheus exposition format on an HTTP endpoint, for example. So there's one step to migration. Another step to migration is the OpenTelemetry collector is similarly versatile. It can ingest formats other than OTLP, and it can transmit in formats other than OTLP. So there is a migration path, and here's another step in our hypothetical migration where we have replaced the pipeline of signals all the way up to the collector, but we're still storing in 3 databases from 3 totally different vendors or projects, and then querying with 3 different UIs. So kind of silly. I want to talk a little bit about some of the cool features of the SDK and also the collector. One really neat feature about OpenTelemetry is its ability to cross-reference observability signals. So a span ID from a trace can be used as an attribute in a log entry and can even be added as attributes of metrics exemplars. So in OpenTelemetry, metrics get a little bit deeper insight into individual events. And so metrics can be tied to, correlated with individual spans and operations that you've observed with those spans. If you think about this for a minute, you can kind of see how we may reach a day when we don't need logs anymore because spans can have logs attached to them. Another neat thing that the collector can do is temporal aggregation, so that in your collection pipeline, you can do things like aggregate on time. Maybe you have a gauge that changes so rarely that or so slowly that it really doesn't make sense to collect it every 10 seconds, but it's being emitted every 10 seconds. Well, within this, your pipeline and your stream of observability metrics, you can do some aggregation. And similarly with spatial aggregation, you can take labels and we maybe call it downsampling if you want. You can take these labels away. You can aggregate on labels. You can use sum to do that. You can just filter by label, And so you have control over these observability signals midstream before they even reach storage. And in this example, we're inferring metrics from spans that flow through our observability pipeline. Tail sampling, another one, if you're familiar with tracing, tail sampling is a really cool feature. Lets you have better control over what you're sampling in your tracing pipeline, and that's just a built-in feature of OpenTelemetry. I believe that feature has actually been put on hold for a little bit. OpenTelemetry is still relatively new. So let's just keep going. All right. So where am I on my notes? That's a great question. Yeah. So in most distributed systems, sampling is critical. With tail sampling, we get that cool feature. And then back to the original question, though, how do we store and query these delightful fire hose of useful observability signals? Naturally, the reason that so many tech companies are behind OpenTelemetry is this opportunity to answer the question. Cloud service providers offer observability pipelines as a value add to their other services, so they compete on convenience. And then APM SaaS solutions have a stronger focus on usability, so they compete more on features. And nothing against this model, but some of us want to have a little bit more control over our data. My experience at InfluxData suggests that many tech companies want to own their data. They want to keep it on premise for a variety of reasons. They want to slice it and dice it with the convenience of raw access to their own data. InfluxDB IOx is the best way to store and query observability signals, in my opinion. All observability signals in this model are stored in one database. You can use SQL, you can use Flux, use InfluxQL, you can use join queries to correlate critical event data in the heat of the moment, answer questions that you never knew you'd have. You can inspect the collective guts of your distributed application in novel ways and ask hard questions of your data in the heat of the moment. By storing your observability signals in Object Store and in something like S3, you can look for clues about today's incident by comparing an incident from last week, last month, last year. Because object storage is so cheap, there's no reason to throw it away aggressively. So you can look for subtle trends over months by sifting through terabytes of Parquet data with a tool like Trino or Spark. In the previous talk, Flink was mentioned. Flink is more of a streaming data pipeline, but Flink is also able to consume Parquet data. All right, so where are we today at InfluxData? We have a schema that we've kind of standardized around a schema for mapping OpenTelemetry to InfluxDB. This schema will consider a new write protocol. So right now we've got line protocol in there. We've got a new write protocol that uses protobuf that will be a little bit more efficient. It's columnar. That's considered in the schema. The OpenTelemetry collector today can send and receive InfluxDB line protocol. Telegraph can send and receive OpenTelemetry protocol, or OTLP. I have a prototype Jaeger UI implementation that does query IOx, but it needs a lot of polish. So that's my talk, and I'd love to take any questions. You can learn more about OpenTelemetry, by the way. I think it's OpenTelemetry.io. Check real quick. Yeah, OpenTelemetry.io. And then I think on my second to last slide, there was a link to GitHub to learn more about the schema and how InfluxData is approaching OpenTelemetry. There's a couple of repositories linked from that link in the slide.
All right, so as we wait for the questions to come through, Jacob, there was one comment from Frank. Maybe we can throw your deck up. It was the slide where you had the telegraphs, the FluentD, the Jaeger. His question was just wondering on the prom expo format if I don't know, he was suggesting that the arrow should be the other way around. Let's just take a look at that.
I think I know just what he's talking about. Yeah, probably. Let's go back to the kind of the vanilla of that slide right here. Yeah, what I meant to do with that particular arrow is demonstrate that it's a pull conversation. So Telegraph is actually reaching out to the application to scrape the Prometheus endpoint and then bring the data in that way. So the application doesn't control the flow of metrics, the collecting agent does. But from that same application, we're pushing logs and we're pushing trace spans. And of course, the intent there was to demonstrate that that's bananas and we shouldn't do it that way.
Cool. Frank says, cool, he's got it now. Awesome. Oops, and Caitlin just says, we're just double checking. I think everybody's just pretty impressed with this, and we're just waiting for some questions to come through. So Jacob, we have a lot of people that attempt to put this kind of data into InfluxDB. And maybe just, to reiterate to our audience, what are some of the problems that they're facing with the current version of InfluxDB if they attempt to put a lot of tracing data in there?
Yeah. Ultimately, it comes down to cardinality, which is a challenge in many databases today. We've known this for a little while, and cardinality is just how varied is your tag set. So you have tag A equals B and C equals D. You have tag A equals C and A equals G and A equals F, and every time that you add a new tag key value to your data set, you've increased cardinality. And so how to get around that has been a challenge for a long time. I worked on this problem a couple of years ago with InfluxData to try to push the boundaries of TSM. When we introduced TSI, TSI is the secondary index that's an on-disk format for TSM, and it improved cardinality by 1 or 2 orders of magnitude. Really, really helpful. But we still kept bumping into problems when we went to scale. And so we decided that a fresh start for this type of problem would be better. IOx is really cool, approaching the problem of not only cardinality, but storing data at scale has been very interesting, and learning that language. Rust is still something that I struggle with. A friend I was with the other day said, I feel like I could pick up any language and it would be fine. And I said, have you tried Rust yet? But it's a fantastic language because it allows us to have better control over resource usage of the application and things like that. So I'm also excited because even the way that we use tracing at InfluxData, tracing and logs at InfluxData internally, we end up throwing that data away after whatever it is, a month or a week, depending on the shape of the data. And that's a shame because very often we'll be involved in some incident or support. We'll be supporting a customer working on an open source bug for a user. And it would be useful to go back a year and say, oh yeah, I remember we have this Slack conversation. We talked about the problem over here. Can we pull up those metrics again? And all we have left are screenshots, scattered around like breadcrumbs in Slack. So I think this is really exciting, being able to store your traces, logs, and metrics locally right next to your application, and then deciding what of those metrics is worth storing forever in something cheap, like the Cloudflare's R2 announcement from a couple weeks ago. I read a bunch of blog posts about that. So cheap to store those dense, rich data for a long time. I think that's going to be a game changer, and I think that being able to control it yourself and deploy IOx right next to your applications this way is just going to be fabulous. I think it'll change the whole way that we approach the problem of observability.
Yeah, isn't it interesting when you don't have it, then that's when we do resort to those screenshots, and we're kind of scrambling to figure out how we can get that view into what we saw even like just a couple days ago.
Yeah,
And
yeah,
we've done, like, I feel like our next speaker actually wrote a couple of really great blogs about cardinality. There's been a bunch of other people that have done trainings on cardinality. But I think at the end of the day, what you and Paul have been telling our audience is that we shouldn't have to train you on cardinality. We're just going to fix it so you could just dump the data and not even think about it. That's the better answer,
yeah.
and that's why I think all of us are really excited about the work that you're doing, Jacob. Because I don't want to talk about it anymore. I just want it to be gone.
I know what you're saying, Chris, and you and Tim, or I know you're just champing at the bit. Every week I hear from Tim. I can't wait to stop saying cardinality anymore. Um, yeah, NACE has had several very uh, interesting blog posts. I learn a lot from her blog posts, in fact, because I'm always down in the guts of InfluxDB, and it's nice to hear and see here at InfluxDays, what the product looks and feels like from the outside, and so, anyways, it'll be a treat to hear her talk, I'm sure.
And even though we do have these limitations, there are a number of community members that have used InfluxDB in its current instantiation to actually build observability solutions. So there are ways to be able to handle it. It's just a little bit tricky. It's not like you
Mhm.
can't. And so I want to make sure our audience understands that it doesn't mean it's a dead end. It just means it's just a little bit of work on your end. But I think when we get this capability out, this would definitely free things up, free some time up for our community members.
Yeah,
Oh,
yeah, we just hate to see people, find different solutions, different optimal solutions for different dimensions of their, what is essentially one problem, observability, and I think that IOX would be a good answer to that question.
and it's not just limited to traces, right? I mean, if we kind of go back a few minutes to the network performance monitoring discussion, even that data can have a cardinality issue, especially if you're trying to understand, what's happening between two IP addresses, right? I mean, I guess it's kind of the same thing, no different than a trace.
Yeah. So I've been harping on tracing specifically and observability generally for a long time at InfluxData, in part because these are tracing is a use case that pushes the boundary of a database of storing time series data, hard in many dimensions, that models well for novel use cases. Um, we have customers doing really interesting things with solar panels and batteries, for example, or um, taking minerals out of mountains. Every time that a new truck is deployed and has a new serial number, well, that's one more stripe of cardinality. Well, that's just one example. We have customers who want to store data forever. We have customers who want to backfill, decades worth of financial data and analyze it that way. Um, and so it's just fun ecosystem to be in, where we get to continue to push the boundary and grow our capability to solve problems for people.
Yeah, exactly. So I'm sure that once we open the doors for this, we'll see a lot of interesting use cases that are going to pop up because people tend to really push the limits really quickly on things.
Yeah, I do. Yeah.
Well, very, very cool. So I guess my last question is, let's say that our community member wants to build a observability platform. What do you suggest they do from a UI perspective? What are some easy things that they can do? And then what are
Hmm.
some more, interesting and maybe a little bit harder to implement UIs that you could suggest?
Yeah, the UI question is still an open one from the open source perspective. Grafana has a great product, of course, and Grafana has ways to visualize logs, metrics, and traces now. In fact, I believe that their current implementation of the tracing UI is borrowed from Jaeger. Um, uh, Other than that, though, the for viewing logs, the InfluxDB or chronograph UI is great for sifting through logs. And I'd like to see a stronger investment in the community to answer this question, because I think that InfluxData has a very unique perspective on the situation, and the community has a much more broad perspective that will bring variety to such a solution. So those are kind of my thoughts on it right now, and I do think about the UI a couple of times a day, probably.
I think that's a really good idea. Let's challenge the community. They're a creative bunch, and I'm sure that now that we've put that challenge out there, something really amazing is going to come back. It's going to be really pleasant for all of us to be able to use.
Thanks for hanging out, Chris.
Jacob, thank you so much for hanging out with us and sharing your work with us. And if you have questions for Jacob, I know this is, this topic is a pretty big topic, but he's here in the Slack channel. He's also, usually in the Slack channel on other days besides InfluxDays. So please feel free to reach out. And I'm sure he'd love to have a conversation about this topic with all of you.